let's see the next concept, which is a very interesting. What is the self induction? Yeah, so this is also called as the inductance of a coil. Actually it is nothing but the property of that coil, so due to which it opposes the change of current flowing through it. Now how exactly it works, now that we are going to see for this particular case. So let's say I will just even will draw it separately. Let's say this is how I can just show. This is that coil. Coil means a straight conductor. You have to take it and just wound, yeah, into a circular loops. So that is nothing but your coil over here. Then connect it across this battery. Again there is one switch. Yeah, so I'm just likewise just showing that, or instead of that even you can just show the switch like this. Yeah, so you have to just make it open and close. Yeah, so even you can just show in this form. Yeah, so let's say this is either I can just make it that switch open or close over here. Okay, so let's say this is nothing but the inductor. So now when you just close this switch, the current starts to flow through this circuit. Again, what is happening over here, there are nothing but the coils. Now the current starts to flow through those coils. So we know that, so this is nothing but, in short, a circular coil. So this is nothing but a circular coil which are over there. So when the current flows through it, obviously the magnetic field starts to produced. Yeah, so when you can say that the current carrying coil is the source of your magnetic field, obviously the magnetic field is linked to that loop. Again, the magnetic field which is linked to that loop, that also we can call it as a flux. Yeah, so that is what we know. That is nothing but the magnetic flux, the number of magnetic lines of force which are just crossing the given area. The area is nothing but the loop itself. So the flux which is linked to the same, you can say that loop, is getting changed since now the current starts to increase. Yeah, so because of which the flux which is linked to that your coil, it getting changed, and because of that the EMF will get induced into the circuit. Now again, one interesting thing, obviously we have seen that Lenz's law, and according to Lenz's law we have seen that now the direction of your induced EMF will act in a such a way that it will oppose the cause. Now what is the cause? Now the cause is because of this, I just make this switch on and the current starts to flow. Yeah, so definitely this induced EMF will oppose the motion of this current. It will oppose that current which is flowing externally through this obviously circuit. So now, so that is also called as a back EMF. Yeah, so obviously it is opposing. It is opposing. Yeah, so that is what we can also call as a back EMF over here. So that is the concept of your self induction. Means obviously the EMF which has been induced. Yeah, so EMF has been induced into the self, into that same coil which will opposes the motion of your current. Now the current doesn't move. Yeah, it doesn't achieve that constant value immediately. It will take some time. So in case of that is your inductor. So we can say for this particular case the flux. Yeah, so the flux which is linked with the coil, it depends on the value of current, or it is proportional to the value of current. If you remove that proportionality constant, then we can write it down that phi is equals to L into I. Then again we know that, so E is equals to minus d phi by dt over here. Then again we can say that, so minus d by dt, and this is Li. Yeah, okay, so what we will do, minus L. Yeah, again this is your di by dt. So you have to just use that. So E is equals to minus L di by dt over here. So just take this one common and minus L di by dt. So that is the same thing which we have written over here. So the self inductance, obviously the unit for that, yeah, so the unit for that is nothing but the Henry. Yeah, so this L again, that is, yeah, obviously E upon di by dt. So this one again you can say this is again the voltage, again this is, you can say that rate of change of current, so ampere per second. Yeah, that is also how we can write it down, but the unit we can write it down in terms of Henry finally. Yeah, so that is what is about your self induction. where we can say obviously the EMF get induced into the same coil through which the current is flowing, and then it will oppose the value of current that flowing through that coil. So that's why it is called as a self induction.